Alright, it's Mr. Smith again, and in this video I'll be talking about truth tables for the conditional and biconditional statements. And so let's go ahead and get started. So first of all, the conditional statement, if P then Q, is symbolized in this way here. If P then Q. Now another way I like to think of it, certainly logically, is that P implies Q. So in other words, if P is true, then Q is implied. All right. So let's go ahead and get started on this truth table. The conditional statement, P implies Q, or if P then Q, is only false when P is true and Q is false. So that's here. P is true and Q is false. This is the only time we get a false statement. In the other cases, we are true. So the basic idea is if statement P is true, then that implies that Q is true. So here, if statement P is true, that implies that Q is true, but it's not. It's false. And so that's when we have a false statement. Now, if statement P is false, then nothing can be implied from that. The only way you can have any kind of implication is if P is true. So we'll try to reinforce that idea in the example below. A couple examples. All right, so evaluate the truth of the following statements. So if Mr. Smith teaches at Brookhaven, which I do, that's true, then he is a Texan. Well, the Brookhaven campus of Dallas College is in Texas, and anybody that teaches there is, I would have to say, is a Texan. It'd be too far to travel from out of state. We're just going to assume that that is true. And so this is a true statement. Remember, when we have P is true and Q is true, that implies that this is a true statement. If Greg Abbott is the governor of Texas, which he currently is, then Lionel Messi is the U.S. president. Well, he's a great soccer player, but he's certainly not the U.S. president, so that's a false statement. So basically, if Greg Abbott is the governor of Texas, this statement, it's implied that this statement should be true, or that it follows, but it's a false statement, and so this is the one case where we get false for the if-then statement. If pigs fly, well, that's certainly false. Then ice cream is a healthy treat. Oh, how I wish it were. But it's not, so this is false, false. But again, if our if statement, our first statement, is not true, then nothing follows. And so I kind of think of this as sarcasm. If pigs fly, you can say whatever you want because pigs don't fly. Nothing is implied because our first statement is false. All right, so this whole statement is considered logically true. It's not considered to be a false statement. All right, so let me try one more time to hopefully make some sense out of this. So consider the following conditional statement. If you get an A on test 1, then you are happy. Well, I guess we're kind of late in the semester, so it's probably not test 1 at this point that you're concerned about, but we'll just go with test 1 here. So our P statement, our first statement, is you get an A on test 1. And our Q statement will be you are happy. So case 1, where these are both true, you did get an A and you're happy. This is P implies Q, and so you got an A on test 1, and P implies Q means that this statement implies the statement here, and you are happy, and so this is a true statement. True, true. So again, our statement is if you get an A on test 1, then you are happy. So getting an A on test 1 basically implies that you're going to be happy. Well, here with the true false, if this statement is false, this statement here, you're not happy. And so we have the true false situation. You got an A on test 1, but it didn't follow that you were happy. And so this is considered to be false. Now, if you do not get an A on test 1, which is both of these cases, then nothing is implied with this P implies Q statement, or if P then Q. And so if you didn't get an A, there's nothing implied, and so this is considered to be a true statement, as well as this one here. So again, basically the idea is if that first statement's not true, then nothing is implied. And so there's no way for that statement to be considered false in that situation. All right, so I hope you get the basic idea. This is one that you got to think about a little bit. It's not as obvious as some of the other ones we've done. Let's move on to the next page. So it says construct a truth table, for not Q implies not P. Well, notice we're going to need not Q. We don't have that yet, so let's find not Q. Basically, we're building this statement. So not Q, well, that's going to have the opposite truth values of what we have under Q. So false, true, false, true. And then we need not P, so that would be, so not P, that's false, false, true, true. So our values are opposite for what we have here in P. And so now we can look at not Q implies not P. Sorry, I got an airplane flying overhead. We'll just shut the door. All right, so let's go ahead and finish this. So we want to know if not Q implies not P. So basically what I like to do is draw the implication arrow here, or the if-then arrow. And so remember, if we have true false, then we're false. So that happens here. Now in every other case, we do not have true false, and so these will all be true. All right, so that's our table for if not Q, then not P. And these are the final answers here for our truth table. So now if you actually consider the truth tables for P implies Q and not Q implies not P, it turns out that the last columns are the same. So what does that tell you? Well, note that the two conditional statements have the same truth value. So basically, these are what we call equivalent statements. All right. We'll talk a little bit more about equivalency later, but basically what we find is the last column is the same for P implies Q and not Q implies not P. So on number 3 here, it says write the contrapositive, and that's something we'll talk about later. That's this one here, which is the one that we were just looking at. So write the contrapositive for the following conditional statement. Now if you eat a burrito at Chipotle, that's going to be our P. Oops, and I forgot the word then. then you will be full. And so that would be our Q statement. And so if you want to write a statement that's basically equivalent, has the same truth value, we would write it in this form here. Well, what's not Q? Well, let's see, this was P. You eat a burrito at Chipotle. You will be full. That's your Q. And so P implies Q here. And so now we're going to say that using this notation here. So not Q, so you will not be full, or if you are not full, then, let's see, then we would have not P, then you did not eat a burrito at Chipotle. So, I don't know if you've ever eaten at Chipotle, but their burritos are big. If you eat a burrito at Chipotle, then you will be full. That is very likely the case. And so something that has the equivalent truth values would be the statement of this form here, not Q implies not P. So let's see if this makes sense. If you are not full, then you did not eat a burrito at Chipotle. Because we know if you ate a burrito at Chipotle, then you would be full. So that's the basic idea. All right, let's move on to example 4. So construct a truth table for, boy, and this is a long one. So we have P or Q and not P. If all of that, then Q. Or all of this implies Q. So we want to build this, and basically I've set this up so that it's built. So first of all, notice we need P or Q. Then we're going to be needing not P. And we'll put those together and we'll get this statement here. And then finally, our last statement will be this one here. And so you can see how we're basically building up to this statement here. And this is what we're looking for, the truth values for this expression, for this compound statement. Okay, so P or Q. Well, we know P or Q is usually true. It's only false when both statements are false. So in all the other cases, it'll be true. So false, false here. It's the only time P or Q is false. Not P, well, that's these here we're going to have the opposite truth values of what we have in the P column. So false, false, and true, true. And so now we can put these together with an and statement. That's what this symbol is here. I like to write it this way here. So you have P or Q and not P. Now remember, an and statement is normally false. It's only true when both statements are true. So that only happens here. There's no other place where we have true, true. So in all these other cases, it's false. All right, so finally, we have this statement here implies Q. Now I like to do this. I'm going to put Q here because it's way over here. It makes it a little bit harder to follow the logic. So I'm going to write Q right here. The truth values for Q are true, false, true, false. And so finally, we get to this here, and we know that a if-then statement or a conditional statement is usually true. It's only false when we have true, false. And in fact, we never have true, false. And so all of these are true statements. So I want to make a comment here. Notice in our truth table at the very end, the last column, each of the lines, each of the cases was true. So this is actually a special case of a truth table or a compound statement. A tautology is a statement that is always true. So for all our possible cases for P and Q in terms of their truth values, this statement is always true. All right, let's move on to biconditional statements. All right, and I think I'm actually going to stop right here, and I'll do a second video. All right, that's it for this video.